Hello, Mr. Wakefield back here with you, moving up to section 7.5 now. By the way, I'm sure you probably noticed we've been jumping around a lot the last few videos as far as the section numbers. We're going to be doing that a lot more moving forward now. I know that can be kind of confusing if you don't have some sort of list of where we're going. Well, as it turns out, first of all, on the syllabus, I do have a list of the sections in order. They are on there on the last page where it has the outline. And also, when you get a new worksheet packet, the order in which I present the worksheets on the announcement where the worksheet packet is, that's the order in which we're going to be doing the sections. So you always will know what's coming next. Okay, but this is all part of the way this class has been set up. At least that's how I've been doing it for the last 17 years in here at Mount Sac. So, and it's the purpose of it is to do all of the equation solving at the same time, and we're eventually going to do all of the word problem type stuff at the same time at the end. Okay, I mentioned this at the very beginning of the semester when I introduced myself. If you don't remember that, but that's why we do that jumping around. Okay. So anyway, speaking of equation solving, we learn how to solve a linear equation, a one variable linear equation. Speaking of one variable equations and solving them, now we're going to be doing more of that, but it's going to be different types of equations with different sets of methods. Okay, so right now there's this thing called the quadratic equation. Okay, first of all, what is that? A quadratic equation is when you have, for example, in this first problem right here, see how both sides are polynomials here? You got one term here, two terms over here. But the difference, unlike the linear equations we saw in the last video, you have x to the second power. Okay, so if you have no parentheses on either side, and if you do have parentheses, you got to ask yourself what would happen after we cleared out those parentheses, okay? And we'll learn about that here in problem D coming up. But if the parentheses are cleared out and the highest exponent that is attached to a variable is 2. See how we got x to the first and x to the second? So the highest exponent that's attached to the variable is 2. When that happens, when you have a polynomial on both sides, okay, then that's called a quadratic equation. You can see that happens here as well. Just a single term on each side, so it's a polynomial, a small polynomial on each side, but the highest exponent is 2. Same thing here. Okay, small polynomial on each side, a single term on each side. In other words, highest exponent is 2. After you clear out the parentheses right here, okay, in fact, I'll do that right now, and then we'll finish up the problem when we get to it. But if I distribute out the w here, what do I get? I get w squared plus 2w. And so that means that, again, you have a polynomial on both sides after you clear out the parentheses. And again, the highest exponent attached to the variable is 2. Highest exponent attached to the variable m here is 2, because you have m to the first and m to the second. Biggest one is 2. So if the highest exponent had been 3, that'd be a totally different story. We don't use the method from this section for something like that. Okay? But when the highest exponent is 2, after you've got any parentheses cleared out, okay, assuming that it's a polynomial on both sides after you clear out the parentheses. We talked about in the first day of class about what a polynomial is, okay? Then in that case, it is what we call a quadratic equation. Okay, I know I've got some stuff written here that I'll explain all that, don't worry. Okay, it's some important stuff here. But what we have here with quadratic equations is we're going to have 4 different methods for solving them. There's a good reason why there's 4 of them. Okay, now since this is the last section of the current worksheet packet, okay, the upcoming exam that we'll be having involving this current worksheet packet will just have this one method here, okay? So the other 3 methods that we'll learn for solving a quadratic equation will be a part of the next worksheet packet, not this one, all right? Just to make that clear, all right? And so in regards to this current method, it involves factoring. Now, as you guys know, some things you can't factor. Some things are what we call a prime polynomial. That's one of the reasons why this method doesn't work all the time. But it will work in this section here, section 7.5. Okay. Let's get into it here. What is the method? Okay, well, you're going to see it's definitely different than the last video. That's why it's important to recognize what is a quadratic equation versus what isn't. Okay. What we need to do is we need to write all the terms on one side of the equation with 0 on the other side. Okay. If there's any parentheses involved, such as in problem D right here, then you get rid of those first. I didn't mention that in the step there, but that's something you need to remember. Okay, so we want to move all the terms. Let's go to problem A here. We'll do that first, as you can imagine. Let's do that first here, and then you'll see how each one of these steps work. All right, so they want us to put all the terms on one side. What that means is that if you don't have any parentheses, and if you do, clear those out first, like I said. But if you don't, then what you do is you add and subtract the terms over to the other side. Kind of like what we did in the third step of the linear equations in the last video, okay, where you add the same amount to both sides. Okay, but you want to put it, and this is where I get to the stuff that I wrote down over here, okay, where you want to put the side that doesn't have the 0 on it into a factorable form. And one of those factorable forms that we learned back in the factoring chapter was when we had x squared, x to the first, and then no x at all. Okay, but we also learned that how to factor this when that first term is positive. Okay, I'm not saying it can't be factored when it's negative, but the method that we learned, the Berry method, and also the other methods as well, depending on how you use it, only works when that term's positive. So you want to do it so that you want to do it in such a way that the squared term, the x squared term, stays positive. So I wouldn't want to subtract this over here because then it would make it negative. You want that to be positive. It doesn't matter what these are. The x term and then the term without the variable in it, it doesn't matter what sign those are. But this has to be positive. So in other words, if you move all your terms to one side, you guys, and you'll see this a lot, and after you get all the terms on one side, if you have all three of these terms, the x squared term, the x to the first term, and the constant term, make sure to put it in this order, first of all. And then also make sure that this is positive. If it's not positive, then move all the terms over to the other side, because if you move the terms over to the other side, it's going to change the sign of them. Remember, you got to, if it's positive, you got to subtract and all that kind of stuff that we learned in the last section. Okay, so for example, if you have, see how here you have negative 24m squared? If it's negative, you want to move that one over here to make it what? To make it positive. You want the squared term where the variable is being squared, you want that to be positive. But here, because that's already positive, the x squared term here, you want to keep it right where it's at. Okay, 4a squared, same thing. You want to keep that right where it's at, even though this is a little bit of a different example. So it doesn't. I'll explain that in a second. But yeah. When your thing is going to look like this right here after you get 0 on one side, if it's going to look like this, you want that one right there to be positive. Okay, so let's try that. So how am I going to make it so that it's the right form here? Okay, I want to subtract and add these over because remember, when you move terms from one side to the other, you got to subtract it if it's positive, and you got to add it if it's negative. That's what makes it cancel. Okay, and so I do the same thing to the other side, minus 3 plus 2x, minus 3 plus 2x, same thing to both sides, just like we did in the last section where we learned how to move terms from one side to the other. Remember over here in section 3.1 to 3.3, we moved terms over from one side to the other by doing the opposite thing. If it's negative a, you added a. Okay, if it was, let me find another example here. If it's positive 3z, you'd subtract. Positive, you subtract. Okay, if it's already negative, you add. That's what we did. Same thing here. So, and then that makes these cancel here. because you're supposed to combine like terms on both sides when you add the same amount to both sides. Okay, and that makes all these cancel. That's what gives you the 0 that we need. It says that you got to have a 0 on one side. Moving all the terms over by adding or subtracting them over will do just that. Okay, it'll get you a 0 on one side. Now, when you have all three of these terms, x squared, x to the first, and then no x at all, three different terms here, that's when you, like I said, that's when you put it in this order. Make sure the x squared term is positive. So I'm going to put it in that order. X squared plus 2x minus 3. Remember, when you have a bunch of terms being added and subtracted, you can put them in whatever order you need to put them in, as long as the sign in front of each term is still the same. X squared is still positive. The 3 is still negative. The 2x is still positive. And also make sure you have a plus or minus in between each term, which I do. Okay, so we did it. Not only did I put 0 on one side, but the side that doesn't have the 0, you guys, that is in a factorable form. There's going to be 3 different factorable forms that we're going to see here. Okay, you're going to sometimes see this right here. Sometimes you'll see this. Okay, the a squared minus b squared formula. If you're having trouble remembering that, I'll remind you. But we did that in the factoring chapter as well. And then also sometimes there's going to be a GCF to factor out first. Okay. And so that's another factoring situation that you need to look at. So, but these are the 2 main ones here, all right, that you need to look out for. So notice here that the positive term comes first and the negative term comes second if it's going to be one of these. I'll show you that in the next problem here, okay? And so keep that in mind as well. But these are the 2 main ones. Just keep in mind that sometimes you got to factor out the GCF as well, because the next step, you guys, is what? It is to take the side that doesn't have the 0 and factor it. Okay, so you want your problem to either look like one of these 2 things right here, okay, or if it doesn't, that doesn't mean that you're stuck. Sometimes it just means that a GCF needs to be factored out. So one of these 3 things is going to be what you need to focus on here when you get the non-zero side. Okay, 0 on one side, the non-zero side obviously being the other side. You can see that this is an example of the first one here. And so we try to factor that. Well, this is one of those Berry method problems, isn't it? Okay, where you, first of all, is there a GCF? You always got to look for the GCF first. Just because it looks like one of these 2 doesn't mean there isn't a GCF. There still could be. I'm just saying that if it doesn't look like one of these 2 things, don't panic. Okay, it could be just that you do the GCF step instead. Okay, but these 2 could still have the GCF also, these 2 forms. All right. So is there a GCF here? Well, it's equal to 1, which means you don't need to factor it out here. Okay, as we've talked about before. So then the Berry method means 1 times negative 3 is equal to negative 3. And then what 2 numbers add up to 2 out of that? Okay, wouldn't that be 3 and negative 1? That adds up to 2, but it equals negative 3 when you multiply them. That's the Berry method. So since we have 1x squared, we're going to have 1x and 1x. Again, if it had been 2x squared, then you'd have 2x and 2x, right? And then you take these 2 numbers and you put them in there. Plus 3 and minus 1. And now these are done here. You don't need to do that step where like sometimes you get the 2 brackets and then one of the 2 brackets breaks down to 2 more brackets. That doesn't happen here. Because why? Because these brackets have 2 terms with x to the first power. We talked about before in the factoring chapter that whenever you have 2 terms in a bracket, in a factoring problem, 2 terms in a bracket with x to the first power, that's automatically prime. That's not going to break down, okay, to more brackets. All right. So we are done factoring here for that reason. Both of these are like that, 2 terms with x to the first power. So what you do now is I want you to realize something here. Okay, in all of these problems in this section, you're either going to get 2 brackets equal to 0, or you're going to get a GCF. It doesn't have to be 2x. I just put that there as an example. You're going to get a GCF times a single bracket equal to 0. You'll sometimes get that. Or sometimes you'll get a GCF and 2 brackets equal to 0. Okay, in these 3 different situations, okay, we'll talk about how to handle those. This is the one we're looking at right now, though. Okay, and here, this is where the next step comes in. It says use the above rule, which is this right here where it says rule, set each of the different factors equal to 0. Okay, let's talk about that. If you have just two brackets on the non-zero side and that's it, and they're being multiplied together, that's two factors. This is two factors. That's why I underlined two things right there. It's kind of like when we were doing the canceling and I told you to underline the factors so that you knew what you can cancel. We're doing the underlining the same exact way here. Okay, two factors here, two factors here, three factors here because we underlined three things. However many things you underlined, okay, that's the amount of things you need to set equal to 0. Okay, it's saying that if you've got two things being multiplied together to equal 0, and it doesn't have to be A and B, it could be just two brackets as well. That means that either the first bracket is equal to 0 or the second one's equal to 0. Okay, so let's write that down and you can see what I mean here. Since we've got two brackets equal to 0, what that means is that the first bracket is either going to be equal to 0 or the second one. You don't need the brackets anymore when you do that because there's nothing else on that side of the equal sign other than just the bracket. There's nothing outside of it being multiplied by it or anything like that. So you don't need the bracket anymore. But you set what's inside of the bracket equal to 0. Okay? So if you've got two brackets and that's it, nothing else, on one side of the equal sign with a 0 on the other side, and this only works if that's 0. It doesn't work if this is any other number. That has to be a 0 there. That's why we had to do that at the beginning, when we had to get the 0 there. But if it's 0, then you set each one of the brackets, the insides of the brackets, that is, equal to 0. And what that does, you guys, is it creates two brand new equations, okay, and they are both linear because you can see that, look at this equation, for example. You have a polynomial on both sides, but the difference is that it's just x to the first power, just like we saw in the last video, okay? You don't have any x to the second or x to the third, okay? It's just a polynomial on both sides, and it's just x to the first power, all right? That's a linear equation. This right here is linear for the same reason. So how did we solve those linear equations? Okay, because we just created two brand new equations here, which are both linear. Okay, they are going to lead to our final answer, but how do we solve those? Just like we learned in the last chapter, or not the last chapter, the last section, okay, we learned that when you have the variable terms and the terms that don't have the variable in it, what do you got to do? You got to move the terms that don't have the variable in it to the opposite side of where the variables are. Okay, and then you divide out after that if it's necessary. It won't be necessary here, but sometimes it is. So wouldn't I move over the 3 with the 0 here? And I get x equal to negative 3, and since x is already by itself, you don't need to divide out. Since this is minus 1, you what? You add 1, and you get x is equal to positive 1. Again, the x is already by itself. You don't need to do the division step. And that is your final answer. Yes, it has two answers. That happens a lot. Not all the time. Not all the time, but it does happen a lot with quadratic equations. You get two answers a lot. Just like with linear equations, you usually get one answer. With these, you usually, but not always, get two answers. Okay, so let's review here. You get all the terms on one side. You factor the non-zero side. You set each one of the factors equal to 0, and then you solve those brand new equations that you just created. Okay? Notice in this next problem here, we don't have all three of the terms. We don't have x squared, x to the first, and constant. What we do have is we have the variable being squared, a squared, but we don't have a to the first power. Okay, so it's not going to be like this one right here after you get all the terms on one side. But it does look like it's kind of trending in this direction, doesn't it? Because you got the 4a squared and the 81. That looks like one of those a squared, b squared things, doesn't it? Okay, because the 4a squared is when you have 2a being squared, and then this is 9 squared. So it looks like it's going in that direction here, but we need to get all the terms on one side here first. Since there's no parentheses, we just go right to it. You can move over the 4a squared, okay? When you do this form right here, the a squared minus b squared. It doesn't matter if the a squared is positive or not. It doesn't. Okay, that's for this one here. The variable needs to be squared on this one, but this one, it doesn't matter. What is important, however, as this cancels here, what is important is that you write this so that the positive term comes first. Okay, see, again, like I said a minute ago, the a squared, which is the positive term, that has to go first, and then the negative term goes second here. All right, so you don't want to write negative 81 first and then 4a squared after that. You don't want to do that. You want to write 4a squared minus 81. Positive term and then negative term. Okay, but this fits right into that because why? As we learned back in Chapter 7 when we had the two terms and we had something squared minus something squared, okay, because of the fact that the 4, the a squared, and the 81, all of those fit into the perfect square list that we've looked at a number of times this semester. There's your 4, there's your a squared, there's your 81. Okay, they all fit in there. That means that I can use the a squared minus b squared formula that I want to use here, all right, or that I'm hoping to use here. I can use it, all right, but what goes in here? Well, 4a squared, isn't that going to be 2a? Okay, 2 squared gives you the 4, the a gives you the a squared, and then the 9 gives you the 81, doesn't it? So again, I'm trying to factor here. Factoring is what you always do in these problems after you get 0 on one side, right? Okay, just like we did in the last problem. And then that's going to give me what here? It's going to give me 2a minus 9 and 2a plus 9. Okay, it's okay to have 0 on the left. I know some of you might be wondering that after the last problem. It doesn't matter what side the 0 is on, you guys, as long as 0 is on one of the sides. And then you factor the other side. That's what's important. It doesn't matter which side's which. Okay, so once again, and these brackets are prime because they both have two terms with a to the first power. That means they're prime. So we got the same setup we have here. Okay, where you got two brackets on one side of the equal sign. Again, doesn't matter which side. Two brackets on one side and then the 0 on the other side of the equal sign. That means what? That means that you set those two brackets equal to 0. Okay. And then you solve those two brand new linear equations. Okay. You're normally going to get linear equations when you do that step. All right. So you just solve them. Okay. How do we solve those? Again, the 9 and the 0 need to be put together. Remember, you're changing gears now, you guys, all right? You're now looking at linear equations, so the steps change. The steps go back to the last video here where there's no parentheses anymore in these brand new equations we got that are linear. All right, I'm sorry I wrote that down wrong. That's a plus right there. That's a plus. Okay, I brought this down. I brought that down over here. You set each bracket equal to 0. But since they're linear, you look at these steps. There's no parentheses. We skip that step. There's no like terms to combine. We skip that step. But then we got to move the what? We got to move the terms that don't have the variable in it to the same side, but it's got to be the opposite side of where the variable term is. That means that I need to move the 9 over with the 0 on both of these, don't I? Plus 9 means you do minus 9. Minus 9 means you do plus 9, right? So that it will cancel. And you get what? You get 2a equal to 9. And then on this one, you get 2a equal to negative 9. And then after you get a single term on each side, again, assuming you're doing linear equations, I'm not talking about quadratic. Okay, quadratic is what we had at the beginning of the problem. The problem has transformed itself into two linear equations. So now, again, we're thinking these steps now. Okay, since they're now linear equations. Looking at the linear equations, what was the last step? After we got a single term on each side here, okay, with a variable on only one side, that's when you divide out, right? It's the same thing here. We got a variable on only one side, but there's a single term on each side. So that means that we divide out. just like we did in the last section. And that gives me what here? Let me give myself some room here. That's going to give me A equal to 9 halves. Or what? A is equal to, on this one over here, it's going to be A equal to negative 9 halves. Okay. So again, you're eventually going to break it down to what will usually be linear equations, and then you solve those. Okay. Let's do that again. Problem C. Notice here that this one looks almost like that, right? But there's a problem here. The y is not on the y to the first power is not on the perfect score list. It's close, but not quite. Okay. So it also obviously doesn't fit into this because there isn't a term without the variable in it. Okay, you've got the y squared and you've got the y, but you don't have this. So neither one of these fit, but remember, okay, you can also try doing the factoring out the GCF, and maybe that'll get us somewhere. In fact, it will. I'm just telling you this. That's how you want to think about this, though. All right, so you might be wondering, well, how do I know which way to move it? Do I move the 9y over here, or do I move that y squared over here? Well, it really doesn't matter, you guys. If neither one of these work, it really doesn't matter. Okay, just move them both to the same side like we've been doing. Doesn't matter which one. I'll go ahead and do the 9y and then do the GCF step, and hopefully that'll get us somewhere here. It will, but again, that's how you want to be thinking. Okay, you want to try that. So I get this right here. The 9y's cancel. Okay. And so then we do the GCF step here. What do we get? What is the GCF here? It's going to be y. If you factor that out, you get y minus 9. And y minus 9 is prime. Okay. Normally, after we factor out the GCF, we try to take our bracket and break that down to 2 brackets, right? But this time, that's prime because it's got 2 terms in the bracket with y to the first power. Remember, if this had been y squared minus 9, now that would factor. But y to the first power with 2 terms in that bracket, that's always prime, isn't it? And as we learned back in the fraction chapter when we were canceling, if you've got a GCF times a bracket with 2 terms in it, since the GCF is just a single term, that's green. Not that you have to make it green here because we're not canceling, so the whole green and red thing's not important. But the important thing is that these 2 things are your 2 factors. When you got a GCF times a bracket, as I mentioned up here, that's when you got 2 factors. And that's very important to realize that we have 2 factors here total. Okay, because those are the 2 things that you need to set equal to 0 on the next step, like this. So if you've got a GCF times just 1 bracket, you set the GCF equal to 0, and then you set the bracket equal to 0. And then once again, we then solve those equations. Again, though, you only have 1 bracket, though, instead of 2 this time because that is prime. That bracket is prime, as we talked about. Notice that this equation is already solved for because y is by itself, right? So you don't need to solve that because it's already done. But this one, don't we need to move, since this is linear again, because it's just y, it's not y squared, okay? You need to what? You need to move over the 9 with the 0, right? To get the 0 and the 9 on the opposite side of where the y was. And then you don't need to divide out this time because the y is already by itself. So once again, you set those things equal to 0. It creates these brand new equations that you solve. You solve them, and then you're done. Okay. Now I want to bring up something important before we go on into the next problem. A lot of students will look at this. Let's start over again. You don't need to write this down here, but I want to make sure you don't make this mistake that I'm about to pretend like I'm making here. Okay. A lot of students will look at this and say, hey, can't I divide both sides by y here? Okay. This is bad, so don't write this down unless you make a note that it's bad. Okay. Can't I divide both sides by y is what some students might think. Well, if you do that and you figure out what each one of these fractions is equal to, you would get what? You would get y over 1, and then over here the y's would cancel. You get just 9 over 1. So you get y equal to 9. And then you say, oh, hey, y already got y by itself. Everything's done. Fantastic, right? No, there's a problem here. There's only one answer here. But in reality, when we did the problem the right way, there was two answers. So that proves that this is wrong because it's one of the answers is missing. Here's the lesson, you guys. And I wrote it down here on a separate answer key here. Do not divide by a variable when you're solving an equation. I know we divide. I know we have variables and denominators in other problems and stuff. Okay, and you'll even see them again here, even in equations. But it'll be in the original problem, though. That's the difference. You do not ever create a denominator with a variable in it. In other words, you don't divide by a variable when you're solving an equation. So if you're trying to solve a one variable equation, you know, when we get y by itself or whatever the variable is, you're trying to get it by itself, all right, you don't ever divide by a variable here. You're allowed to divide by a constant number, like 2. 2 is not a variable. 2 doesn't have a variable in it. It's okay to do that, and we've done that many times. But you're not allowed to divide by something that has a variable in it while you're in the process of solving an equation. And you can see why that's bad here. It left out an answer here when we did that. Okay, so do not divide by a variable when solving an equation. You can divide by, as we've done many times, you can divide by something like 2, okay, because that doesn't have a variable in it. Okay, so wanted to make sure that you made a note of that as well, because again, it could lead to a answer here where one of the numbers is missing from the answer. We don't want that. Okay. Okay, moving on in here to problem D. As I said, when you do those that first step here, putting all the terms on one side, put it into the right form here. Make sure that if there's any parentheses that you need to get rid of them first by distributing it out. Just like you do at the beginning of a linear equation in the last section here, we always distribute out the parentheses first. Okay, when you do the factoring method for solving a quadratic equation like we are here, you do that, you get rid of any parentheses that you have first. Okay, just like you did with linear equations. I already did that, as I mentioned a few minutes ago. Okay, so now we're ready to do the rest of the problem. Notice, though, that we have what? We have w squared, we have w to the first, and then we have a term without w in it at all. So it's going to end up being like this, isn't it? Where you got w squared, w to the first, and then no w at all in this last term. So when you move all your terms to one side, make sure that it's in this order, w squared, w, and then no w at all. And then also make sure that the term that has a w in it, or sorry, the term that has a w squared in it, make sure that's positive. Okay, so because the w squared already is positive, we want to keep it right where it's at. If I subtract the w squared over here, it's going to make a negative, and then we can't factor it using the methods we learned back in chapter 7. Okay, so the best thing to do then, really the only thing to do then, is to move over the 48, because you don't want to move these two terms. It would make the w squared term negative. We don't want that. So I move the 48 over. That makes that 0 right there. And remember, after you clear out the parentheses, the way you move the terms over is to add or subtract them over. So you get the 0. Make sure to put the terms in the correct order over here. The w squared goes first, and then the w, and then the term that doesn't have any variable in it goes last. Okay? That's because we want it to look like this, like we said. All right, so I've done that now. It now looks like a Berry method problem from chapter 7, okay, because of the three terms here that we have. So we have 1 times negative 48. Obviously, that's equal to negative 48. And then you need to figure out what two numbers equal positive 2 in the middle when you add them together. Wouldn't that be 8 and negative 6? 8 and negative 6 multiply together to be negative 48. But they also add up to positive 2 in the middle. And so how does this factor out? This becomes w plus 8 and w minus 6, because we got positive 8 and negative 6 here. Just bring that down here. We don't need to do the last step of the Berry method. I did not forget about the last step of the Berry method. We just don't need to do it here. We also didn't need to do it here because the GCF of each bracket is equal to 1. So it's not going to, if you try to do that last step of the Berry method, it's not even going to change what you already have. So that's why I skipped it. It's not going to make any difference in this case. So once again, we got two brackets on one side of your equal sign. They are prime, okay, because you got two terms in each bracket with w to the first power. That means their brackets are prime, okay. So we are done factoring since each one of the brackets is prime. And then we what after we're done factoring? We take each bracket, because of the fact that you just got the two brackets. We saw that in problem A and in problem B. If you've got just the two brackets equal to 0, you set each one of the brackets equal to 0, and then you solve the brand new linear equations that you just created. How do we do that? We need to move over the 8 with the 0, and then we need to move over the 6 with the 0, so that the W term will be on the opposite side now as where the 0 and 8 were, or as the 0 and the 8 will be, okay, which will be on the right-hand side. Same thing over here. 0 and 6 are now on the opposite side of where the W is. So what do we get? We get W is equal to negative 8, or W is equal to positive 6. Since W is by itself in both of these equations, we are done with both of those equations. Okay, remember, you're solving each equation separately, though. Don't be trying to combine the equations together in any kind of way. Just solve them separately. Once you've done that, you're done. Okay, ultimately, you want to get x by itself, or in this case, w by itself. Okay, that's what it means to solve a one-variable equation, which is what we have here. Okay. Last one here before I ask you guys to try some. Okay, again, we have... we don't have any parentheses like the last one, but we have an m squared term, we have an m to the first term, and we have a constant term with no variable in it. So that means we want to be thinking about this right here. M squared, m to the first, no variable at all in this last term. Okay, so you want to put it in this order when you get it all on the same side. And you want the m squared term to be positive. Okay, how am I going to do that? Well, since the m squared term is currently negative, you want to move it so that it'll become positive. Remember, if you want to change the sign of it, you move it, right? If you want it to stay the same sign, then you keep it right where it's at. So we get 24m squared. Since 4m is positive, I got to say plus 4m. Remember, you got to have a plus or minus in between each one of these three terms here. So put that plus there if it's positive. And then minus 48. That remains negative because we didn't move that term. And then there's a 0 on the other side because these cancel. You get a 0 there. Okay, what's different about this problem as we get into the factoring step now is that there is a GCF here, okay, not like this one here, because this problem had only two terms. This one looks like a Berry method problem, but it also has a GCF. So just because it looks like this, as I mentioned earlier, doesn't mean you don't still have a GCF as well. Any problem could have a GCF when you factor it. So let's factor out that GCF. It's going to be 4, just 4. And then we get 6m squared plus m minus 12. Then, as we learned back in the factoring chapter, after you factor out the GCF, you try to factor the remaining bracket. And as it turns out, it will factor this time, unlike problem C, where the bracket was prime. Okay, the y minus 9 was prime. This time it's not. 6 times, and you'll see why here. I know it's hard to see that yet, but when I try to do the Berry method here, you'll see that it works, because negative 72 is what we got when we do 6 times negative 12, but it needs to add up to 1 in the middle here. Wouldn't that work for 9 and negative 8? 9 and negative 8 they multiply to be negative 72, but they add up to a positive 1 in the middle here. So we end up with 6m plus 9. and 6m minus 8. But remember, you guys, we got to do the last step of the Berry method, or at least try to. In this case, it will make a difference. As we always do when we do factoring problems, though, if you have a GCF from the original problem, not from the last step of the Berry method, but from the original problem, keep on bringing that down. Okay, it is a part of the answer. But if I factor out the GCF out of this first bracket, which is going to be equal to 3, if I factor that out, I get 2m plus 3. So we get rid of that GCF out of the last step of the Berry method, like we learned in Chapter 7. And then this has a GCF of 2. If I factor that out, I get 3m minus 4. And again, you throw out the 2. Okay. As I mentioned, and these brackets are now prime because they got two terms with m to the first power. Okay, so we know that means prime. So then this is the first time we've seen this, but as I mentioned earlier, if you have if you have a GCF followed by two brackets and all three of those things are being multiplied with a 0 on the other side, then what you do is you have three factors there, okay, the GCF and the two brackets, just like we learned how to underline factors in the fraction chapter. But then you set all three of these equal to 0. Okay, that's how that works. So if you've got a GCF and two brackets all being multiplied together with 0 on the other side, what you do is you set all three of those equal to 0, and then you solve those equations, just like we've been doing on the other problems. Pardon me, I'm running out of space here a little bit. Okay, I squeezed it in there. I'll zoom in there for you. I know that's kind of small. There we go. So I then need to solve these. But what we learned in the last section 3.1 to 3.3, is that when you have an equation with no variable in it and it's false, 4 and 0 are not equal to each other, so that's false, right? What did we learn about that from the last section, you guys? We learned that when it's false with no variable, that means no solution, right? But I want to make it clear here, you guys. That's just for this equation, because all three of these equations are independent of each other. So if this one does not produce a solution, you guys, that does not invalidate the other two. Okay, the other two equations could still produce an equation separate from the 4 equal to 0 equation. So it just means that this equation doesn't produce any answers. But that does not mean that the other two equations couldn't produce an answer. Okay? So, this equation has no solution, but these two still could. Let's solve these in the normal way here. You got to move over the 3 with the 0. We get 2m equal to negative 3. You then divide out by 2. You get m is equal to negative 3 halves. And then on the other one, you have to move over the 4 with the 0. Like that. We get 3m equal to 4. You then need to divide out the 3 like we've been doing with linear equations. And we get m equal to 4/3. Okay? Usually when you get a fraction answer, when you're getting the variable by itself, okay, you can leave the fraction as it is as long as you put it in lowest terms. You don't need to make it into a decimal in your calculator usually, unless I tell you otherwise. Okay, but put it in lowest terms if it's not already. These fractions already are in lowest terms, so that's fine. I'm just reminding you. But again, usually you don't have to make it into a decimal. Just keeping it as a lowest terms fraction is fine. Lowest terms fraction as an answer is usually fine. Okay, so sometimes the GCF does give you an answer, though, as we saw up here in the GCF giving the answer of y equal to 0. It's just that in this case it didn't. So don't misunderstand, okay? Sometimes the GCF will give you an answer, as we saw in problem C, but this time it didn't here in problem E. Okay, so it just depends on the problem. Okay, what we got left here in this section is 3 more problems on the front side of the worksheet. and then 2 problems on the second page of the worksheet for 7.5. Okay. And so here they are right here. Remember we talked about how when you got a bracket at the beginning of a quadratic equation, clear that out first and then move all the terms to one side. Okay, and even though this doesn't look like a quadratic equation, as we talked about in problem D here, after you clear out the parentheses, that's when you determine what kind of equation it is. Okay, and that's important to understand that, because even though you know all the equations in this section are quadratic, on the test I'm not going to necessarily tell you which ones are linear and which ones are quadratic. So I need you to understand that. Okay, so get rid of your parentheses first, you guys, then figure out what the biggest exponent is. You can see here after I clear out the parentheses here, the biggest exponent is x to the second. Whereas in the previous video, even after you got rid of the parentheses, you still didn't have any second power, did you? You just had a to the first, a to the first, a to the first. That's what made this linear. The fact that it was still a to the first and no a to the second, even after you got rid of the parentheses. But here, even though it looks like there's no x to the second at first, if you clear out the parentheses, then the x to the second appears. Okay, so it all has to do with what you got after you clear out the parentheses. If you've got x to the second as the biggest exponent, then it's quadratic. Okay? If you've still got no visible exponents, it's just x, or if it's just a with no x to the second or a to the second, then that would be linear. Okay, so do those 5 problems, hit the play button after that, and we'll take a look at those answers. Okay, number 1, you can see here that we have the x squared term, the x to the first term, and the constant term. So we're kind of leaning towards this format, aren't we, right here? Okay, where we need the x squared to be positive. Since we need the x squared to be positive, we want to move over the 12, don't we? Okay, because you got a choice here when you move all the terms on one side. You either move the x squared and the 4x over with the 12, or you got to move the 12 over with the x squared and the 4x. Okay, so that's the choice, but there's really only one correct choice here, because you want to make the x squared positive. Since it already is positive, keep it right where it's at and move the 12 over like this. Okay, then what do you do after that? You then factor what you got. All right, and I ended up with x plus 6 and x minus 2. How did I get that? I did the Berry method. Okay, 1 times negative 12 gives me the negative 12. 6 and negative 2 are that's the 2 numbers that add up to 4 in the middle there, and so that's why I picked those. So we ended up with x plus 6 and x minus 2. Both of those brackets are prime, so I can then underline those and move on to the next step, which is to set each one of those factors equal to 0. And then I solve those resulting linear equations that I get. And I get x equal to negative 6 and x equal to positive 2 when I get x by itself. Okay? Number 2. All the terms are already on one side, and not only are they already on one side for us, but they are in this form here, aren't they? They got the t squared and then the t to the first and then no variable at all. Okay, so they were nice to us on that one, weren't they? Okay, they already set it all up for us. All right, now we just need to factor that. Okay, we end up getting 4 times negative 30 is equal to negative 120. And then these are the 2 numbers that add up to negative 19 out of that. So again, I'm doing the Berry method here. I went ahead and went up here with that. Okay, I just showed the work in a little bit of a different place there. 4t plus 5 and 4t minus 24. But I got to factor out the GCF out of each bracket to complete the Berry method. This one already has a GCF of 1, so it doesn't change anything there. Okay, but then this you have to factor out the 4, and you get t minus 6 on that one there. And so here's the factoring there. These brackets are prime because they both have 2 terms with t to the first power. They are prime, so I can then set the brackets equal to 0 like I've been doing. and then I solve those brand new linear equations that I get. Since they're linear equations, I need to move over the 5 with the 0 before I divide out the 4 right there. That's that one. Over here, I just need to move over the 6 because then after I do that, the t will already be by itself. So you create these brand new linear equations and then you solve them. All right? All right, number 3. You can see again, they've already got all the terms on one side, and you can see also that it is, it fits right into this format, doesn't it? The a squared minus b squared, because the 4x squared and the 9, all of those things are what? They are all on the perfect square list. If all the different parts from each of the two terms are on the perfect square list and you have a minus in between them, that means you can do the a squared minus b squared formula in order to factor that. And so it ends up being, because it's 2x and 3 that's being squared there, 2x minus 3, 2x plus 3 are the two brackets that you get. Again, those brackets are prime for the same reason as the other ones were in the previous two problems. So you set each one of those equal to 0. You get the two linear equations, okay, that we oftentimes get. And then we solve those linear equations, okay, by moving over the 3 with the 0 before you divide out the 2. Because, you got to get, in a linear equation, you got to get the variable term by itself before you can divide out. I did that by moving the 3 over. I then divide out the 2 to get the x completely by itself, and your final two answers there are 3/2, as you can see here, or -3/2. Okay, so that is the first page of the worksheet. We got those last two problems on the second page here. Let me pull that up. Here it is over here. Oh, wait, hold on. It's actually over here. There we go. Problem number 4. Again, you got to distribute this out first, like I talked about a few minutes ago. And now I can see that it's going to fit into what? It's going to fit into the x squared x, no x at all format. All right, so that means I want the x squared to stay positive by moving the 2 over to the other side. All right, so that, because again, the x squared, like I said, that term has to stay positive if it already is positive. And so we did. X squared is positive. It's in this order right here. Then we could do the Berry method when it looks like that. Okay. The Berry method gives me what here? It gives me -2 and +1. Because you do 1 times -2 is -2. Those are the two numbers you get because they add up to -1 in the middle. Okay. X minus 2 and x plus 1. And then what? And then now that those are done, we're done factoring that, we set each one of those equal to 0. We solve those resulting linear equations by moving over the 2 and the 1. Final answer, 2 and -1. Okay, finally, number 5. All right. We get, in number 5, we get... we got to distribute that out first, don't we? Just like here. We do that first in a quadratic equation. And we can see here that after we distribute that it truly is a quadratic equation. Okay. Remember, you don't know for sure until you clear out your parentheses, but we now know for sure because we have a polynomial on both sides, and the highest exponent is 2. That means quadratic. But it has those 3 terms in it, doesn't it? It has x squared, it has x to the first, and it has a constant term with no variable in it. Since it's in that form right there, you want it to be in this order with the x squared term being positive. Since the x squared is already positive, I want to move the 20x over and put it in this order so that it will be in the correct form. Okay? I then do the Berry method 3 times 12 is 36. The two numbers that add up to negative 20 in the middle are going to be what? Negative 2 and negative 18. I put those in there. Remember, since it's 3x squared, you got to do 3x and 3x, not just x and x this time. And then you do the rest of the Berry method, 3 factors out of that bracket. Okay, the other bracket stays the same. So you got your 2 brackets here. We're done factoring. We set the 2 brackets equal to 0. It creates the 2 brand new linear equations. We solve them, and there's your final 2 answers right there. X equal to 2/3, x equal to 6. And so that is how you solve quadratic equations using the factoring method. Like I said, the other 3 methods for solving a quadratic equation will be in the next worksheet packet. We are now done with the current worksheet packet. And so if you see a quadratic equation that you have to solve on the upcoming exam that involves this current worksheet packet, all right, it will be one in which you'll be able to use the factoring method because that's the only method you've learned. So you don't need to be responsible for knowing the other 3 methods until after this upcoming exam, the one that involves this worksheet packet, is over, okay? And not until after that exam's over do you need to be concerned about the other 3 methods that are in the next worksheet packet, okay? So just want to make sure that's clear. But yeah, let me know if you have any questions, not only about this section, but the entire worksheet packet, okay? But otherwise, have a great day, and we'll see you back in the next video for those for the second of the 4 methods for solving a quadratic equation. Take care.